Okay, in this video, we're going to go over percent composition, how to calculate percent composition, and how to use percent composition if you were given it to backtrack and find different quantities of a substance. So percent composition is the term used to describe the percent by mass of each element in a compound or each part in a mixture. If we're talking about a mixture as opposed to a chemical formula. In general, when we are looking at percent composition, this is our basic formula. It is the part of something out of a whole times 100 is the percent. So think about this in terms of like your classes, right? You have, just as an example, 30 people in a class, right? If I wanted to find the percent composition of the class based on the male and female distribution, right? I would count up the number of males and put it over the whole. So let's say 12 over the 30. It's a small male class, right? Mostly female dominated class. So 12 males is the part, 30 is the whole. So 12 divided by 30 times 100 gives me the percentage of males, right? You understand this concept outside of the world of chemistry. The moment I bring it into the world of chemistry, you're like, what part over whole? I don't understand. If I want to do the females, right? The number of females over the total population of the class times 100 is percent. If we wanted to break it down by grade level, right? How many juniors in that class of 30 times 100 is percent, is the percent juniors, right? So part over whole times 100 is percent is all that we're doing. If I'm asking you to break it down from a formula, it's the part of the formula that is sodium out of the whole formula. Or if I'm asking you to find the mixture, like the ingredients, how much of my total batch of ingredients is this one part? Part over whole times 100 is percent. Or if I give you the percentage, going back and finding either the part or the whole. So very useful kind of arrangement of data that we have here. So there's 3 different methods to use or find percent composition that you're going to see in this class. The first one is from a formula. So I give you a formula and I say, find the percent composition of the formula. Find the amount of each element in said formula. So your steps here. First, got to find the whole, you got to find the molar mass. Once I have the molar mass, remember, I had to find parts of each element to find the molar mass, divide the mass of each part by the total mass. So we're only going to do one example because, again, this is predicated on the fact that we have already talked about how to find molar mass. So we've already done most of this. So what's my formula here? This is aluminum dichromate. So I'm going to find molar mass, which we already know how to do. Break this down into the parts. I have aluminum, I have chromium, and I have oxygen. How many aluminum do I have? I have 2. How many chromium? 3 times 2, I have 6. How many oxygen? 3 times 7, I have 21. Okay. So then where do I go? I'm going to go to the periodic table. I'm going to look up the atomic mass of each element. So aluminum, 26.98. And then I'm going to find chromium right here, 51.99. And we know oxygen is 16.00. Okay. So I'm going to do my math. So 26.98 times 2, 53.96. And then 6 times 51.99 for my chromium, 311.94. And 21 times 16.00, 336.00. All right, so when we were talking about molar mass, I said, don't be lazy and just put 16 because it's going to cause you sig fig problems later down the line. Well, here we are later down the line. When I am doing my percent composition, my sig figs come from here, whatever these were from the periodic table. Okay, so if I only wrote down 16 and it's supposed to be 16.00, I'm going to think, oh, I'm only allowed to have 2 sig figs, and that is not right. Okay, so keep that in mind. All right, so I'm still not done finding the molar mass. What's the last thing I need to do? I need to add all these up. I need to find the total. So I'm going to do this off camera so I don't have to keep putting my calculator up there. 53.96 plus 311.94 plus 336.00 is 701.90. So what do I have here? What's going on? This is my whole, right? That's all those things together. And these guys are my parts. And my formula is part over whole times 100 is percent. So what do I need to do? I need to divide each of my parts by the whole. So let's do that. 701.90, 701.90, 701.90. Oops. Part over whole times 100 equals my percentage. So let's bring the calculator back up here. 53.96 divided by 701.90 times 100. All right. My sig figs for that, I can have 4. So 7.688%. And that should make sense, right? 53 out of 700 is not very much. So 7% seems reasonable. 311.94 divided by 701.90 times 100. How many sig figs can I have? Oh, 4 again. So 44.44%. And then for my oxygen, 336.00 divided by 701.90 times 100. 4 sig figs again, 47.87%. Okay, so I can leave it like this, and that's fine because I labeled it over here, or I can also rewrite it. I'm not that picky. If you wrote it like this in a straight line, you have your identifying element all the way to the left and your answers all the way to the right. It's fine. If you want to rewrite it, it's fine too. But there's my answers. So my compound, aluminum dichromate, is 7.688% aluminum, 44.44% chromium, and 47.887% oxygen, which should make sense also considering like 6 chromium and 21 oxygen. Yeah, that's going to be bigger than 2 aluminum. Okay. Still, part over whole times 100. Part over whole times 100. That's all we're doing. Okay. All right. So that was from a formula. Our second example is what happens if I say, well, here is this mixture from a mixture. So first step, add up the parts to get a total. If the total's not given, the total might be given, right? Reading comprehension. If it's not, add up the parts to get a total. Then divide the parts by the total, right? Part divided by whole. So our question this time is determine the percent of each element in a mixture of 16.3 grams of carbon, 7.2 grams of hydrogen, and 10.43 grams of oxygen. So here it's important to know I've got 3 individual parts. The sig figs from the individual parts are from the individual parts, which means each of these, because they have different numbers of sig figs, are going to have different numbers of sig figs in the answer, and that's okay. All right, so carbon, hydrogen, oxygen, 16.3 grams, 7.2 grams, 10.43 grams. Add them all up. Let's get our total. So 16.3 plus 7.2 plus 10.43, 33.93. All right, there's my total. So part divided by whole times 100. All right, so let's see, 16.3 divided by 33.93 times 100, 48.048. So sig figs, I can have 3 48.0. Then I need to do my hydrogen, 7.2 divided by 33.93 times 100. I can have 2 sig figs this time, so 1, 2, 21. And then the last one, 10.43 divided by 33.93 times 100. 4 sig figs, 30.74%. Okay. Part divided by whole, part divided by whole, part divided by whole. That's all we're doing. All right, let's look at our last method of using percent composition. So this time, we're going to go backwards. Talk about how do you find the part. If I have the percent of each part and I have the whole, how do I find how much the part was? Okay, this is just algebra. Make the part x, right? So make this x, make it a variable. You have all the rest of the things, solve for x, right? How do you isolate x? Well, what are you going to do first? You're going to divide by 100. Divide by 100. That's going to leave you x over the whole equals some number. Then multiply by the whole. That gets you x by itself. And this is all algebra. You can do this. So a compound has a mass of 26.4 grams. That's my whole. And it's 70.00% carbon, 25% hydrogen, and 5% oxygen. Find the mass of each element. So notice we've got a sig fig parade here, right? I've got 3, I've got 4, I've got 2, and I've got 1. So sig figs are going to be by the measurement. Okay, sig figs by the measurement. So I need to look at each one as I go. All right, so let's just break it down by element. Let's find the carbon first. So carbon, x over, that's my part, the whole, 26.4 grams times 100 equals, what was my percentage? 70.00%. So what do I do first? Divide by 100. So divide this across. So x over 26.4 is equal to 0.700. I should be able to do that. Move the decimal 2 places, divide by 100. All right. Now I have x over the whole is equal to what is left of my percent. I need to isolate x, so I'm going to multiply across by my whole. So 0.7000 times 26.4 gives me 18.48. X is equal to 18.48. Now I need to consider my sig figs. This had 4, this had 3. I can only have 3. So 1, 2, 3, the 8's going to round, 18.5 grams of carbon. So out of my 26.4 total grams, 18.5 of it we have just determined is the carbon, which should make sense because 70% is the carbon, 25 and 5 are the other two, so it should be the most. All right, let's do the hydrogen. Same exact thing. X over the whole, 26.4 times 100 is equal to the percent, 25%. Divide by the 100. So I'm going to move my decimal 2 places to the left. X over 26.4 is equal to 0.25. All right, 0.25 times 26.4 is going to give me x equal to 6.6. Now check my sig figs. I had 3, I have 2, this is 2. Oh, I'm good. I don't even have to redo this one. So 6.6 grams of hydrogen. Remember, unit and substance, unit and substance. All right, and my last one. I need to figure out how much left is oxygen. Oxygen, x over 26.4 times 100 is equal to 5%. Divide by the 100, x over 26.4 is equal to 0.05. And then 0.05 times 26.4 gives me 1.32. All right, sig figs. 5% had one sig fig, 26.4 had three. I can only have one. The 3 doesn't round, so 1 gram of oxygen is what is in my compound. Okay, so using the formula part over whole times 100 is percent to find the part when you have the percent is the one for some reason students have trouble with. The math is easy, but it's like you're not sure when to use it. If you have a percentage given to you in this problem or a previous problem, that's what you're doing. Okay, so if you're given a percentage and you're asked for pieces, okay, solve for x. And so you gotta keep telling yourself, gotta just solve for x. If I solve for x, I can get it.